Okay. Hey everyone, how you doing? Everybody pumped after watching that Bear Grylls talk? I know I am. My name is Brad Bock, and I'll be giving this talk about DevOps in real time with Bitnami and NSX. Here's the obligatory disclaimer. Just take a second to read that, if you would. Good? All right. So who am I? I've been at VMware for about a year now, or a little over a year, doing product marketing in the networking and security business unit. Covering the whole portfolio of NSX products. So everything from NSX Cloud, even things like SD-WAN and NSX-T data center. And what really attracted me to to NSX was this concept of the virtual cloud network, kind of connecting all of the applications and services and data that you might have running in different environments all over the world. As the number of places you can run code explodes, so does the difficulty with maintaining the network and the security that you have for all of those things. So I was really attracted to that. You can see we've got a big portfolio of products. Today we're going to focus on NSX-T data center and NSX Cloud. And that's going to enable us to deploy an application that's distributed across both environments. And then, so I used to work at Bitnami as well. So I was there for 3.5 years. I left Bitnami for VMware in August of last year. A few months later, Bitnami couldn't stay separated, so they decided to come join me at VMware. So you guys, who here has heard of Bitnami? A few of you? Okay, so basically what Bitnami does is it packages open source software and it makes it available anywhere, in any cloud, any platform, for any open source application that they package. You might have heard that slogan before, any. So they've got over 180 applications and components, which encompasses everything from fully self-contained applications like WordPress to databases or all the things that you need to actually build your own code into apps. And they publish them on I think over 20 different platforms now. So AWS, Azure, Google Cloud, Oracle Cloud, but also in containers, which, as you know, can run anywhere, and they're tested on all of those platforms. So like EKS, AKS, GKE, you name it. And they've even got them for your native or for your local machine. So you can deploy these things to any of these places, and they run consistently the same across all of them. So say you've got a Node.js app and you want to run it, you can add your code to that, and it's going to run the same way in Azure as it does in AWS, as it does on-prem or on your laptop. Bitnami's got a really sophisticated pipeline that automatically monitors all of the code and updates it whenever there's a change, not only to the code itself, but it monitors thousands of different sources of information about vulnerabilities and outdated libraries for Linux and all of that stuff. And when it detects a change, it automatically pulls that code, or whatever the change is, rebuilds all of its assets and republishes them everywhere. So over 1,000 releases per month on average. Really popular with developers, over 1 million installs per month, and really popular with the cloud providers because the software is available for no charge to the end user, but it generates a lot of revenue for the cloud providers, over 1.5 billion instance hours per year. So today we're going to talk about kind of the meeting of developers and operations. So and how Bitnami and NSX work together to enable those things. So we just discussed how Bitnami is enabling workloads across a whole bunch of different environments, and that's great, right? Like everybody loves to be able to deploy applications everywhere, but now you have to learn a new sort of networking and security constructs for each of those platforms. So NSX provides the kind of one extended cloud fabric through which you can manage the networking and security for all of these things. We're going to cover a demo app. This was made by the VMware Cloud Advocacy team, so check out their GitHub. You can also see their blog at cloudjourney.io. There's a lot of great information there on cloud-native applications. You can see it's a microservices app, so we're going to deploy it on PKS Enterprise in our data center. Except for one thing, there's a MongoDB here for order and checkout. It's called Acme Fitness. It's like an e-commerce website. We're actually going to deploy that MongoDB in AWS, and we're going to manage it as if it was on the local network. So we're also going to use Bitnami's package GitLab Community Edition Ci Cd. So we've got a pipeline that we've defined here. So we're going to start with the code. So all of the services or the containers that we're building on our own code are pulling Bitnami containers that are trusted to run on all these platforms. The pipeline will then rebuild those containers when it detects a change in the environment. It'll push them to a container repository. In this case, we're using Docker Hub, but you could just as easily use Harbor if you wanted to deploy it in your data center. And the last thing we'll do is in the pipeline is push an update to a Helm chart. So Helm, if you don't know, is a package manager for Kubernetes applications, and it essentially describes everything Kubernetes needs to know to deploy that application successfully. And finally, we're going to deploy it in kubeapps, which is a Bitnami open source project that enables you to manage the life cycle of your Kubernetes applications in a graphic interface. So deploying the application, updating the application, rolling back updates, deleting the application, all that stuff can be done through kubeapps in a GUI. Finally, we're going to look at the database that we're replacing with the AWS instance is going to be the Bitnami MongoDB. So you can get this in the AWS marketplace. It's absolutely free. You can get it from Bitnami's website. And this will just stand in for that service that was going to be running on Kubernetes. So there's basically 3 tiers here. We have our enterprise PKS running Kubernetes on-prem with the Acme Fitness e-commerce app and kubeapps. One thing I forgot to mention here is that we have a chart repository that we deployed ourselves called Chart Museum. That's also running in our cluster. So yeah, we've got Kubernetes Enterprise PKS with Acme Fitness and kubeapps. We've got vSphere with our GitLab source control repository and our Ci Cd, and we have AWS with a MongoDB. So the developer is going to change the source code and make a commit to the Git repo. GitLab is going to detect that and start the pipeline process. GitLab runner will build the containers and a new Helm chart, and it's going to push those out to their respective repositories. And then we'll switch to kubeapps where the new chart update will be available. So I'm going to start a video. This is a kind of a video of the demo, and I'm just going to apologize in advance that it's going to be a little bit small on this screen. So if you can't see what's going on, I would encourage you to take a look at this online afterwards as it's being recorded. So the first thing we're going to do is find our MongoDB on the AWS and in the Bitnami marketplace, kind of going through all the different versions of that we have here. And we're going to select the AWS version and copy that AMI ID to our EC2 console. We're going to deploy that. Going to add a couple of tags so that NSX will recognize that when it goes live, and we've already connected NSX Cloud to this VPC, so NSX will automatically know when this EC2 instance starts up. So a couple configuration pieces, and then we're going to deploy that. He's going to install an agent on it, and that's what gives you the full capability of NSX. You can actually do that agentless if you want as well, but then you're limited to AWS native security functions. So we've got our NSS.network tag, our app tag, values. So now we're going into Cloud Service Manager. This is within NSX, and you can see we have the application running with the same private IP address that it had in AWS EC2 console. Whoop. Sorry about that, hold on. Okay, we're back. So we've got our MongoDB running in AWS, but as you can see, you're seeing it here in NSX Cloud or in NSX. You've got your IP address, which looks like it's on a local network. The next thing we're going to do is we're going to deploy GitLab on-prem. So Bitnami makes a GitLab Community Edition OVA file that you can deploy. You can get that in the VMware Cloud Marketplace as well for vCloud Director or VMC on AWS. And as you can see, there's no cost, and we're going to deploy that in vSphere just as we would deploy any application. And as you can now see, we've got that running in our, or discovered by the network for NSX as well. So we've already configured Kubernetes with Enterprise PKS on premises, and you can see all of these logical ports here represent pods. So you can see the name of the services like that were in our architecture diagram. And you can see the tags, and as long as developers apply these tags when they're deploying their application, the right security settings are automatically applied to the application. So kind of takes away the need to manually do this stuff or to file a ticket. It just happens. So we're going to create a really basic security group that encompasses all of the parts of our application. And you'll see we'll set some membership criteria. So it's going to be logical ports, virtual machines with the tag Acme Fit equaling app. On the bottom one, you can see there the scope is equal to discovered AWS app. Essentially, that means that NSX discovered that through NSX Cloud. So we look at the members of that security group, and you can see we have all of the assets here looking through the logical ports view. These are all our services. We have all of the containers that we deployed to AWS visible in NSX. Right there, because these are all in the same security group, we've now got all of our assets, containers, VMs, and cloud instances all in the same group. So you can see here, if we switch to virtual machines, we can see the MongoDB running in the cloud. We can see the GitHub or GitLab as well. So the next step we're going to do is we're going to create some there we go. Okay, we're going to create some firewall rules just to kind of show how this works. So it's going to be a microsegmentation policy. So basically controlling the traffic that goes east-west between application tiers, but in this case, it's going to be between the application tier that's running on-prem and the database, which is running in AWS. But as you'll see, it's the same as if it was all in the same physical space. So it's going to select the app tier and add that as the from rule. It's going to select the database tier, which is going to get our MongoDB instance. This will actually apply to other MongoDB containers that are also running in this environment as well. And then we're going to set the type of traffic. So in this case, protocols and ports that are normally MongoDB traffic are going to be allowed. So the purpose of displaying this or showing this is just to show that this is what you normally do for applications running in your data center, but in this case, it's spreading that security rule out to AWS. So now we're going to see the point of view of the developer. So he's in GitLab. He's got his source code here for Acme Fitness. He's actually going to do a search for Bitnami, and it's going to show how basically what all of the Bitnami containers that are being used in this, that the code will be built on top of. So you can see there's quite a few containers in there. It'll also deploy MongoDB Bitnami containers as services. So there's a Redis container that was in that architecture. There's another MongoDB. So he's already cloned this to his laptop. He's creating a new branch. He's going to make a change to the homepage that free returns are for 6 months instead of 3 months. So, very basic change, just meant to show how this process works. It's also going to make a change to the version of the Helm chart so that kubeapps recognizes there's been an update. Now he's going to commit this to his Git repo. Just put a Git commit message. And he's going to push that to the GitLab that's running in our data center. Next, he's going to switch over to the Gitlab Ci Cd, the pipeline. And you'll actually see that this process is already running. So you'll click into that so you can see what assets are being built. So these are all of our containers here. And I think it takes, this is not sped up. I think it takes around just a couple minutes for everything to actually be built. And you can see we've got the first few digits of our commit message in there, or our commit in there, so we know this is the diff that it recorded. So we've got the commit that we just made here in GitLab. So those are almost done. One more. And now it's pushing those out to the respective repositories. So we've got all of our containers now pushed to our Docker Hub, and our Helm chart is now updated in Chart Museum. So now we're in kubeapps. This is the interface. We're going to switch to the namespace that we created for this, and you'll see Acme Fitness there. And there's an update. There's a new Helm chart. He's going to give it a name, Acme Fitness Temp. He's showing that you can see the latest commit there from GitLab. He's going to change the service type to load balancer so that we can access it over the NSX load balancer that will be created as this is spun up. And he's going to give some information about how to connect to the database running on AWS. So he hit deploy. He's going to switch back to the other namespace. This is the running Acme Fitness that we already have. It's going to come up really quick, but you can see an update is available, so it actually detected that a change happened. And it's also got the IP address of the application, which is local, because he's got a VPN into the data center, so he's able to see that. So it looks like all of our services are almost up. And so now you'll be able to access that at the URL. And again, this is just the IP address of the load balancer that was just deployed. And you can see that he's got the change, the free returns for 6 months has happened there. And the last thing he's going to do is kind of as I guess proof that that it's actually able to write to the database, he's going to run a helper script that will access MongoDB and print the last record that was recorded. So you can see we've got some data here. Again, this is coming from our database in AWS. Now he's going to go and actually create an order through this fake e-commerce site, and then show the update in the MongoDB instance itself. Just take just a second to complete that. Obviously, just some dummy data he's sticking in there. The method of delivery, Sean's tractor. Some fake credit card information. And then we're done. So he's going to run that helper script again and just show that, it did indeed write that. So delivery tractor got the same, address that he entered in Palo Alto, et cetera. So that's it. That's the demo. I mean, I think it's a really simple example, but you can see the power of this. You're able to do all of these things automatically. When that new version of Acme Fitness was deployed, all of those security policies that you created are automatically applied, and they apply across your entire environment, including, really what's a virtual cloud network, right? It's encompassing both your data center, VMs, containers, and assets running in AWS. So that's it for the demo. I want to see if anybody had any questions before we wrap up. Any questions? I should have seeded some. All right, well, thank you very much for joining. I hope that was useful. And like I said, if it was hard to see on the screen, take a look at the VMworld portal after this, and it'll be available starting tomorrow. So, all right, thanks.